March 1st, 1954, Bikini Atoll. The countdown reaches 0 and a blinding flash erupts from the Pacific. But something is wrong. The mushroom cloud is climbing higher than anyone expected. The heat is more intense, and the fallout is spreading in directions the scientists never predicted. Within hours, radioactive ash begins falling on the crew like snow. The bomb has yielded 15 megatons instead of the planned 6, nearly 3 times more powerful than predicted. But how did America's top scientists get their calculations so catastrophically wrong? And what impact did this bomb have on humans, nature, and the future? Well, it's time to find out. To understand this disaster, we need to look at the intense pressure driving nuclear weapons development in the early 1950s. The Cold War arms race had pushed both the United States and Soviet Union far beyond the atomic bombs that ended World War II. The Soviets had tested their first hydrogen bomb in August 1953, achieving a 10-megaton yield that demonstrated their thermonuclear capabilities. American military leaders needed to prove they could build a deliverable hydrogen bomb that matched this power.
The atom bomb is here. It exists. We must look to the future.
The pressure was enormous, and confidence was high. The team at Los Alamos National Laboratory had spent years working on fusion technology. Unlike the atomic bombs dropped on Hiroshima and Nagasaki, hydrogen bombs used nuclear fusion instead of fission to create energy. Fusion bombs worked by forcing hydrogen atoms together under extreme heat and pressure, releasing massive amounts of energy in the process. The scientists had run smaller tests and worked through thousands of calculations. They believed they had mastered the science behind these weapons. Edward Teller led the hydrogen bomb development program. His team had created detailed mathematical models that predicted exactly how much energy their new bomb design would release. They calculated the Castle Bravo device would produce about 6 megatons of explosive force. That would make it roughly 400 times more powerful than the Hiroshima bomb, but still within manageable limits for a controlled test. The scientists had confidence in their numbers because they had successfully tested similar designs before. The military chose Bikini Atoll in the Marshall Islands as the test site for good reasons. The location seemed remote enough to contain any radioactive fallout within a safe zone. Bikini sat in the middle of the Pacific Ocean, hundreds of miles from major population centers. The military had used Bikini for nuclear tests before without major problems. They established evacuation zones around the atoll and calculated safe distances for observation ships and aircraft. The bomb itself represented the cutting edge of nuclear technology in 1954. Scientists had designed a 2-stage weapon that used a fission bomb as a trigger to start the fusion reaction. The device weighed approximately 10,000 pounds and stood over 14 feet tall. Inside the weapon, lithium deuteride served as the fusion fuel. The scientists planned to use 2 different types of lithium in the fuel mixture. Lithium-6 would participate actively in the fusion reaction, while lithium-7 was thought to be much less effective fuel than lithium-6, and so largely inactive. This fuel composition became the key to their confidence. The team calculated that only the lithium-6 would contribute significant energy to the explosion. Lithium-7 made up about 60% of the fuel mixture, but the scientists believed it would contribute minimally during the reaction. This assumption formed the foundation of all their yield predictions. Military planners used these calculations to determine safety zones around Bikini Atoll. They believed a 6-megaton blast would confine fallout to a 50-mile radius from ground zero. Ships positioned themselves at distances the scientists said would be safe. The closest observation vessel sat 30 miles from the test site. Aircraft planned to fly at altitudes and distances calculated to avoid dangerous fallout levels. The confidence extended to radiation monitoring as well. Scientists set up instruments designed to measure the expected 6-megaton blast. They prepared equipment to track fallout patterns based on their predicted yield calculations. Everything appeared under control based on the scientific models. But the scientists had made a critical error in their understanding of lithium-7. Under the extreme conditions inside a hydrogen bomb, lithium-7 would not remain largely inactive as they predicted. Instead, the intense neutron radiation from the fusion reaction would convert lithium-7 into tritium, which would then undergo fusion itself. This meant roughly 60% of their fuel mixture would participate actively in the explosion instead of sitting idle. The miscalculation had enormous implications. If lithium-7 reacted as violently as lithium-6, the bomb would produce far more energy than anyone expected. The careful safety zones, observation distances, and radiation monitoring equipment were all based on a 6 megaton yield. The team proceeded believing they had created a controlled demonstration of American nuclear power. What they did not realize was that their fundamental assumptions about the bomb's fuel were wrong. The final preparations for Castle Bravo revealed just how unprepared everyone was for what was about to happen. Percy Clarkson's film footage of the blast. The massive ball of superheated gas and plasma grew at an alarming rate, consuming everything in its path. Scientists watching from observation ships could see the fireball was much larger than they had predicted. The sheer size of the expanding inferno told them immediately that their yield calculations were wrong. Within 10 minutes of detonation, the mushroom cloud reached 130,000 feet high, punching through the stratosphere and into space itself. The cloud climbed much higher and faster than expected, creating a massive column of radioactive debris that stretched far into the upper atmosphere. Weather tracking equipment showed the cloud continuing to rise well beyond the altitude scientists had planned for. The explosion completely vaporized the artificial island where the bomb had been placed. Nothing remained of the carefully constructed test facility that had taken months to build. Seismic stations around the world detected the explosion, registering vibrations thousands of miles away. Scientists in Japan, Australia, and California recorded the shock waves from Castle Bravo on their instruments. The seismic readings showed an energy release far greater than the 6 megaton prediction. Scientists studying these readings knew immediately that something had gone wrong with the test. Radiation monitoring equipment began showing readings so high that scientists first thought their instruments had malfunctioned. Geiger counters on observation ships started clicking rapidly. The explosion was more than twice as large as anyone had calculated, making it the most powerful nuclear weapon ever detonated by the United States. The lithium-7 isotope had undergone unexpected nuclear reactions, turning what should have been inert material into additional fuel for the explosion. Under the extreme conditions inside the hydrogen bomb, neutrons converted the lithium-7 into tritium, which then participated in the fusion reaction. When the 15 megaton explosion vaporized Bikini Atoll, it pulled massive amounts of coral, sand, and seawater into the mushroom cloud. This material became intensely radioactive as it mixed with the nuclear debris. The fallout cloud then carried these contaminated particles eastward on the wind, dropping them across hundreds of square miles of ocean. Crew members who handled the powder directly suffered beta burns on their hands and exposed skin. The men were unknowingly exposing themselves to an estimated 290 roentgens of radiation, compared to the maximum safe exposure of 3.9 roentgens. Radio operator Eikichi Kuboyama reported the strange phenomenon to other fishing vessels operating in the area. He contacted several Japanese boats by radio to ask if they were experiencing the same unusual ashfall. Within hours of the ashfall, crew members aboard the Lucky Dragon 5 began experiencing the first signs of acute radiation sickness. Several fishermen complained of nausea and severe headaches that seemed to come from nowhere. Others noticed their skin becoming red and painful, especially in areas where the white ash had made direct contact. The symptoms appeared gradually, starting with mild discomfort and becoming more severe as the day progressed. The boat carried a Geiger counter that the crew normally used to check for radioactive contamination in their fish catch. This was standard equipment on Japanese fishing vessels because of concerns about atomic testing in the Pacific. When crew members pointed the Geiger counter at the white ash covering their boat, the device began clicking rapidly and showing extremely high radiation readings. The readings were far higher than anything the fishermen had ever seen before. As more hours passed, the radiation symptoms became impossible to ignore. Crew members developed severe burns on their skin, particularly on their hands, faces, and necks, where the ash had made contact. They tried washing the ash off their boat and equipment, but the Geiger counter continued showing high radiation levels. The contamination had penetrated deep into the wood and metal surfaces of the vessel. When they tested their catch of tuna with the Geiger counter, the fish showed dangerous radiation readings. By the time the Lucky Dragon 5 returned to its home port of Yaizu, Japan 2 weeks later, all 23 crew members were suffering from severe radiation poisoning. The men were immediately hospitalized as doctors struggled to treat their symptoms. Their hair had fallen out, their skin was covered in painful burns, and their white blood cell counts had dropped to dangerous levels. Japanese authorities tested the boat's entire tuna catch and found radiation levels thousands of times higher than safe limits for human consumption. The contaminated fish had to be buried as nuclear waste, representing weeks of lost work and income. News of the radioactive tuna spread quickly through Japan's fishing industry and created widespread panic about Pacific seafood safety. But the Lucky Dragon 5 was not the only victim of the massive radioactive cloud drifting eastward across the Pacific. Rongelap Atoll lay 100 miles east of Bikini and sat directly in the path of the radioactive plume. Small Coral Island was home to 64 Marshall Islanders who lived in traditional villages and relied on fishing and farming for their survival. The residents had no warning about the nuclear test. American officials had not told them about Castle Bravo. The islanders had no shelter designed to protect against radiation and no understanding of what nuclear contamination meant. By afternoon on the day of the test, the same white ash that had covered the Japanese fishing boat began falling on Rongelap like toxic snow. The radioactive particles settled on houses, gardens, drinking water sources, and everything else on the island. Some islanders were told by passing military personnel that it was harmless snow, according to eyewitness accounts. Children played in the radioactive dust without any understanding of the danger, building games with the contaminated material and getting the particles on their hands and clothes. The islanders went about their normal activities while radiation levels climbed to dangerous heights. Women continued washing clothes in contaminated rainwater that had collected in barrels and containers. Men kept fishing in lagoons where radioactive particles were settling into the water and coral. Families ate meals prepared with contaminated water and served on surfaces covered with radioactive dust. The entire community was being exposed to massive doses of radiation without knowing it. The contamination spread across a much wider area than American scientists had predicted. Islands that officials considered completely safe were receiving fallout levels hundreds of times higher than normal background radiation. The radioactive cloud continued moving eastward, dropping contaminated particles across hundreds of square miles of ocean and inhabited land. It took the United States military 2 days to begin evacuating the islanders from Rongelap. The evacuation began on March 3rd, meaning residents continued living in heavily contaminated areas while radiation exposure built up in their bodies. The delay happened because American officials initially didn't realize how far the fallout had spread or how contaminated these islands had become. When they finally understood the scope of the problem, military ships rushed to begin emergency evacuations. When rescue ships finally arrived at Rongelap, Geiger counters showed radiation readings nearly 1,500 milliroentgen per hour, prompting immediate concern according to USS Philip logs. The contamination was so severe that military personnel had to wear protective equipment while evacuating the islanders. A total of 230 people from 3 atolls were evacuated, and would not be allowed to return home for years. American authorities declared their islands too contaminated for safe habitation. Some families were separated during the evacuation and housed on different islands. The displaced communities lost their traditional homes, fishing grounds, and way of life because of a weapons test they never knew was happening. Even today, some areas of these islands remain contaminated with radioactive materials from Castle Bravo. The half-life of some isotopes means certain parts of Rongelap will stay dangerous for decades or even centuries. Entire communities had been displaced by the Cold War arms race, becoming unwilling victims of America's quest for nuclear superiority. Officials classified images that revealed the massive scale of the explosion and the extent of the fallout zone. Journalists and photographers who had documented the test were told their materials contained sensitive national security information that could not be released to the public. The censorship prevented people from seeing visual evidence of how much larger the blast had been than predicted. Officials described the islanders' radiation doses as minimal and comparable to routine medical procedures. Atomic Energy Commission spokesman told reporters the exposure was about the same as a medical X-ray and posed no serious health risks. This characterization made the evacuation seem like an unnecessary precaution rather than an emergency response to dangerous contamination levels. American authorities classified most details about the Castle Bravo test, including the crucial fact that the bomb had yielded 15 megatons instead of the predicted 6 megatons. The yield miscalculation remained secret for years, preventing the public from understanding why the fallout had spread so much farther than expected. Officials also classified information about the lithium-7 fuel reaction that had caused the unexpected power increase. The cover-up efforts intensified when AEC Chairman Louis Strauss held a press conference on March 31st. Strauss claimed that fallout from Castle Bravo had been minimal and repeated the assertion that the Lucky Dragon 5 had been operating inside the danger zone. His misleading statements, captured in press transcripts, suggested that proper safety measures had been taken and that the Japanese crew had ignored warnings. These public denials intensified international outrage as evidence mounted that contradicted official claims. Anti-nuclear protests erupted across Japan as citizens learned about the contaminated tuna catch and the worsening condition of the Lucky Dragon 5 crew. Japanese fishing unions organized demonstrations demanding answers about the safety of Pacific fishing grounds. Housewives boycotted fish markets out of fear that seafood might be radioactive. The protests grew larger as news spread about radio operator Aikichi Kuboyama's deteriorating health. Officials also had to admit that their safety calculations had been inadequate and that the test had caused unintended harm to innocent people. The incident revealed that even the most advanced scientific planning could not prevent nuclear weapons from causing unpredictable devastation far beyond their intended scope. The consequences of this miscalculation extended far beyond the immediate victims. Castle Bravo demonstrated that nuclear weapons are fundamentally unpredictable forces that can never be fully controlled. A routine test became a disaster that affected thousands of innocent people across the Pacific. The incident led directly to the 1963 Limited Test Ban Treaty and showed the world that the arms race had consequences far beyond the superpowers conducting it. Today, the Marshall Islands still deal with contamination from Castle Bravo. Rongelap remains uninhabitable decades later, and according to the 2013 Defense Threat Reduction Agency report, the people evacuated from Rongelap, especially children, have suffered medically from their fallout. Exposure. The true cost of nuclear weapons extends far beyond their intended targets, affecting generations of people who never consented to the risks. What lessons from Castle Bravo do you think apply to today's world? Let us know in the comments below.